Hello, everyone. Can you hear me? This is Jonathan Schrex with Arista Networks.
Yes, sir.
I think we'll jump started. My name is Jonathan Schrex. I'm with Arista Networks. I'll be your first presenter for today's Virtual Campus Builders 2020 event. Before jumping in, first and foremost, I want to wish everyone joining us today and their families all the best in hopes you're all staying safe and healthy during these incredibly surreal times. I'm sure in some ways this recent crisis will change the way we socialize, interact, and it's all being evidenced by this virtual meeting format today. Certainly going to provide new ways of conducting business professionally for all of us as well. That said, we'd like to thank all of you for spending part of your morning with us today. We're certainly excited about the agenda and the content we've created, and so we're eager to share it. We will follow up afterwards to gain feedback and perspectives from all of you on how you're viewing next generation campus and wireless architectures as well. Throughout the presentation, there will be opportunities for you to post questions in the chat window, and if possible, we will attempt to address them in real time or during a natural breaking point in the presentation. If not, we'll certainly address your questions directly at the conclusion of our meeting today. In addition, we will be offering a series of multiple choice questions by which the first attendee to answer those correctly will be sent a prize. We have a number of different prizes for you, including Yeti mugs and backpacks and lots of other really great items. As you probably saw in the looped introduction slides, you're going to hear from a total of 5 presenters today, all of which are subject matter experts here at Arista in areas of campus and wireless architecture, network access control, and we certainly know in today's virtual world that we're currently living in, security is an important piece of any modern campus architecture. And finally, you'll hear from one of our experts on how Arista is helping its customers implement the easy button when it comes to implementing rich automation, visibility, and orchestration. So again, thank you to everyone joining us today, and let's quickly review our agenda and get started. So as mentioned earlier, we are living in a truly virtual world these days, and like this session, we are all likely familiar or using frequently tools like those from Zoom. So the CEOs from both Arista and Zoom have put a brief video together they wanted us to share with you all. We will then take a quick look at who is Arista. For some of you on today's call, this may be your first ever exposure to Arista or the company, its products and its technologies. We'll then dive deep into next generation campus architectures, followed by a small break, and then we'll close today's meeting with details on our efforts and integration activities with Forescout, as well as a deep dive into how to automate and orchestrate the new campus and wireless infrastructure while gaining deep analytics and visibility into your workflows. All right, so let's take a quick look at this video today.
Eric, it's always a pleasure to meet with you, and today is a special day. Like every day, I want to start by saying we're 2 companies that pioneered in our respective fields, Arista in the cloud and you in redefining collaboration. If you look a decade ago, we both were barely existent or just startups. And today we are so relevant, not only in our market cap, but also in terms of the type of enterprise and cloud customers we serve. How does this experience feel to you?
Actually, you are right on. Arista is a leader in the software-defined networking industry, and Zoom is focusing on software-defined cloud video conferencing. And we built a solution for serving the business and enterprise customers. However, during this pandemic crisis, suddenly we have hundreds of millions of new users. And on the one hand, we feel very proud of serving those new customers. On the other hand, we also feel huge pressure how to serve those new users better.
Well, I think you, of all companies I know, take this responsibility very seriously, as does Arista. What strikes me as something, again, we both have in common is we have a common technique to disrupt the legacy, change old habits. And this is really important. You always have to question what you do next from a technology innovation perspective, from a go-to-market customer perspective. And I know every time I get down from airports, which I haven't done recently, I can see that big Zoom banner. It makes me very proud.
Yeah, thank you, Jishu. You are my mentor. Arista is our role model. Every day we think about how to disrupt the existing legacy players, how to have a disruptive business model, and how to innovate. That is very important for our company, this size, to keep growing.
Absolutely. So speaking of being your role model, I'm working on how to make Zoom more and more effective. Arista launched the Cognitive Campus last year. And this year in 2020, we'll be launching for the first time how to make Zoom work better on the cognitive Wi-Fi applications, prioritizing, troubleshooting. As you know, network bandwidth is great, but access to that bandwidth and prioritizing it with the type of service and troubleshooting is becoming more and more important, especially as you access millions of users and the aggregate users have to be appropriately prioritized. Are you running into this problem as well?
Yes, you're so right. Actually, since several weeks ago at home, quite often I have 3 or 4 Zoom meetings running at the same time with the same Wi-Fi. Sometimes I had a quality problem. Maybe my daughter, she's using Zoom, and my son, right? How to make sure, how to troubleshoot at the QoS, and that's very critical. And almost for every family, for every, the office as well in the future.
So when I talk to customers, we talk a lot about client to cloud and the whole user experience. And obviously the network plays a mission critical role. But I'm sure you have a view or two on user experience. How has it changed over the years for you?
So you are right. So when we look at the cloud, SaaS player normally look at the cloud infrastructure and also the client. And the client side more likely to deploy the experience. But the key is about the backend side. How can you have a secure, very scalable cloud infrastructure, or like what Arista technology offers to the cloud service providers?
So one last question, Eric, and if there's one piece of advice you want to give to our readers and customers, or one word you want to describe all of this in, this is a great opportunity. And the word that comes to mind for me when I think of Arista and Zoom is Arista in Greek means to be great. And Zoom, well, collaboration king. Keep on zooming. What do you think about the Arista Zoom collaboration?
Meaning care. Both of us, we care about the community, end user, society. We do all we can to care about the customer, to deliver the best experience to them.
Well, Eric, keep on caring and keep on zooming. Congratulations.
Thank you, Jayshree. I really appreciate it. Thank you.
So I think after watching this video, we should all take pride, as we're all mostly technologists, at how well the global internet has operated during this pandemic, how much easier it has been for us to stay connected, maintain some semblance of a normal work environment, collaborate with our families, friends, work colleagues, customers, and so forth. It's a testament to the kinds of innovation and engineering prowess that's being brought to us by companies like Zoom that have allowed us to enjoy this sort of continued human interaction. So we certainly thank Zoom for their partnership, and we thank them for making this technology available to us all. So let's focus now a bit on Arista and who we are. So Arista recently achieved a pretty major milestone, celebrating its over 10 years now of shipping platforms. We started back in 2004, but didn't start shipping products until about 5 years later in 2009. So you may be asking yourselves, what was Arista doing for 5 years? And the answer is pretty simple. Unlike many Silicon Valley-based companies that have fairly short runways to conceive, build, and go to market with their technology so they can provide a return to their investors, Arista, being funded by 2 Silicon Valley legends, was given 5 years to build a ground-up next-generation operating system, the specifics of which and the value of which will be shared in coming slides today. But it's the levels of quality, reliability, and programmability that we brought to market with our operating system, known as EOS, that has resulted over the past 10 plus years now in the adoption of our technology by some of the largest and most demanding networks on the planet. And Arista launched its OS and associated merchant silicon-based platforms during a time when many of our competitors were positioning closed vendor lock-in alternatives, fabric technologies like QFabric, FabricPath, Trill, and others. So Arista was the pioneer for an open standards-based leaf-spine two-tier architecture, which allowed customers choice at any layer and doing so at massive scale. So it's really these principles in quality, scale, and reliability over 10 years that has won the hearts of some of the largest financials, cloud, federal, and service provider customers that Arista now wants to bring to the enterprise campus. We continue to enjoy financial health, evidenced by our continued quarter-over-quarter and year-over-year growth, and we're growing our market share. We're very proud of the fact we hold the #1 spot in global 100 gig port shipped, and the #2 spot in global 10 gig port shipped. And while some of you on the call today may not have had much, if any, exposure to Arista, you are likely using Arista in your everyday lives and didn't even realize it. With over 22+ million ports shipped and Arista powering some of the largest networks in the world, from the time you wake up until the time you go to sleep, you likely touched Arista infrastructure in some way multiple times during the day, whether it was uploading photos to iCloud, booking an online ticket, although we're not doing much of that these days. If you're buying or selling stocks or moving workloads into the cloud, or certainly these days watching lots of Netflix, Arista systems are powering all those major networks across media and entertainment, travel, financials, cloud, service provider, and federal. And while we have a full suite of platforms that range from 1 gig to the M gig standards we see in the new campus today, with 2.5 and 5 gig, all the way up to 400 gig. Some of these systems we'll actually share details about today. What our customers have truly appreciated from Arista is the ability to have been able to maintain a single operating system across all of our product portfolio. This certainly eliminates the frustrations around feature disparity, platform reliance, and poor quality that comes with having to maintain multiple images across varying families of product containing inconsistent features. Some of you may have heard of Gartner, highly reputable analytics firm. Many of our customers rely on Gartner every day to decide on which vendors to investigate further, where certain vendors excel and in what areas, and how likely they are to provide viable solutions. For the past 2 years, Arista has been recognized in the upper right quadrant, and last year we were especially proud of our continued shift up into the right, evidenced by Gartner's confidence in our ability to execute and our completeness of vision. All a testament again to our one operating system approach and the laser focus that we have on doing what we do best and staying in our core competency, which is building world-class platforms and software for our customers. Arista is also fairly proud of the kudos it gets and the praise it gets for our global support model. Unlike our competitors, Arista does not contract any of its personnel. All of our TAC professionals are Arista employees. There are no tiered TAC levels. You will not call Arista and get a level 1 TAC person who can't fix the issue and gets escalated to a level 2 TAC individual and so forth. The average resolution time for our TAC cases is around 30 minutes, and the average time to respond to a call is less than a minute. So we're very proud of the levels of quality and support that we're providing to Arista customers. It's also evidenced by the scores you see there, net promoter scores, 76 and a 9.1 out of 10 overall rating. And then a quick overview of some of our customers. As I mentioned a few times so far this morning as part of this introduction, Arista's technology has been adopted across multiple verticals in high performance compute, in media and entertainment, large financial services, all the hyperscale cloud providers, large federal organizations, so forth and so on. So we have a wide breadth of customers that we've learned from and that we're building solutions for. And that carries over into our federal organization as well.
You want me to pick that up, Jonathan?
Please, Scott.
Yep. So just give a quick snapshot. You'll find that Arista is well represented over the last 8 years in the federal marketplace. That is in the intelligence communities, civilian agencies, the Department of Defense, and then of course the federal systems integrators and the partner community that bring their total solutions to the environment. So I appreciate those of you who are joining the call today. I can see that you're representing both end users, partners, and our federal systems integrator partners. You'll find that our solutions do meet requirements and have the certifications required to be deployed and operate in these environments. And we should be easy to contact here around our Mid-Atlantic base. The team I run, I'm Scott Wilson, supporting the federal business unit here. My associates, you'll find a number of them on the call today to keep track of the questions from the attendees. But we are easy to contact. I would urge and support that, Jonathan, if you jump to the next slide, that you do contact Judson Walker, who you'll hear speaking a little later on today, and then myself. We're easy to find through all manners of direct contact at Arista or through LinkedIn, or probably you've already got some level of engagement with us today. Again, we are widely deployed in the Department of Defense, civilian agencies, and the intelligence community. Specific product sets and verticals you're going to hear about today in the campus overview, but you will find that on the cloud, the migration to the cloud of these key critical customers, and also in the interconnectivity of their on-premise data centers, you're going to find Arista already in there right now, even if it was put in with the compute application and storage provider. So look forward to serving to support you and supporting that high-value customer, Fortune #1 enterprise, federal government. Jonathan?
Great, Scott. Thanks for sharing that, and congrats to you and your teams for achieving all of the necessary accreditations and certifications that many of your federal customers require. So moving on, so we're going to dive. We're going to have Judson, take on the next section. But I wanted to provide a few slides to level set what we're really going to be focused on today. As you can imagine, we find ourselves at a point of change in the campus, evidenced by new wireless standards, such as 802.11ax or Wi-Fi 6, and then the associated need for higher powered PoE systems that are in many ways required and needed to facilitate things like intelligent power management and mGig, 2.5, 5 gig standards. All of this is aimed at reducing downtime, reducing operational complexity, giving customers increased visibility. And that's certainly compounded by the explosion in IoT and technologies such as that. Without jumping into a lot of specifics here, as many of you have probably experienced over your careers in network infrastructure and networking, we're moving away from multi-tier, multi-stage architectures that are usually fraught with high oversubscription, lack any ability to scale out, normally utilize different product families at every layer of that architecture, which introduces more operating systems, more complexity, more operational burden, feature disparity between one platform and another, so forth and so on. And we're trying to move and evolve that into a more standards-based, scale-out, two-tier leaf spine architecture. Again, I mentioned this earlier. This is an architecture that Arista prides itself on pioneering. It's an architecture that is widely used in some of the largest networks in the world. And Arista sees an opportunity to take all the lessons learned, from our cloud customers, service provider customers, hyperscale customers, and translate that down into the new campus enterprise. So you may be familiar, or you will become familiar with a popular term that we find ourselves here at Arista utilizing, which is UCN, or Universal Cloud Network. And this is simply an attempt by this slide to highlight some of the layers of a campus infrastructure that are utilized to facilitate certain workloads, whether they be IoT, whether they be traditional data center, hyper-converged, and all of this needs to be managed, and high levels of visibility and analytics need to be provided seamlessly. So, with Arista's campus solutions, the functionalities that you'll find in our software around analytics and flow data, combined with our CloudVision product, which provides kind of a universal single pane of glass for orchestration, for telemetry and analytics. This is what we're calling kind of our cognitive campus, the ability to implement technologies like AI and ML, high levels of visibility and telemetry, to give customers complete views into their campus infrastructure and have a universal cloud network that facilitates all sorts of workloads and applications. This dives a little bit more specifically into some of the principles that Judson and Sean and Adam will cover later in the presentation, but it sort of breaks it out into this concept of leaf spine. And on this slide, you'll see management leaf, border leaf, campus spline, services leaf. The idea here being is that once we've implemented a standards-based approach, a tier 2 leaf spine design, then we can allocate certain leaf switches to certain application functionality, whether it be peering leafs to leave your data center, whether it be storage leaf infrastructure that front ends massive storage clusters, and all of this is managed through what I mentioned earlier is an offering by Arista called CloudVision. So this provides a single ingest engine for all of the switches in your Arista infrastructure, will stream analytics into CloudVision and provide single pane of glass capabilities around telemetry, analytics, orchestration, automation, all of these things that we'll highlight as part of today's virtual meeting. So in closing, with a few slides here before we dive into specifics, sometimes there's just a better way to do things. Sometimes companies get the opportunity to start from scratch, to start from the ground up, and to build something unique. So as I mentioned as part of some of the intro slides, in 2004, we set out on that journey, and we spent 5 years building a next generation network operating system. This is a published, subscribed sort of database-centric system that 10 years later has resulted in unprecedented levels of quality, reliability, feature velocity, and programmability. In many ways, we built this software offering in advance of cloud titans and the explosive growth they've experienced, because we knew that the industry needed an operating system that provided all of the capabilities I just mentioned. So today, our operating system powers some of the world's largest data centers. We are very prideful in the quality that we're experiencing with our software. Throughout many of our competitors, there are different ways that these competitors implement quality assurance or QA. At Arista, we had the opportunity here in the early days of our onset to build very large data centers full of Arista switches where we run 250,000 automated tests on every feature across every platform for every release of code. And if you listen to Ken Duda speak, and there's YouTube videos that you can access, he makes it very clear that quality is the most important attribute of our products. It is not one of the most important, it is the most important. It's something we're very prideful on, and it's something our key customers appreciate us delivering on. And this is also evidenced by how vulnerable we find our software. This is an analysis of some of the most popular common vulnerabilities that have been experienced in our industry across a set of competitive technologies. And in the life cycle, in the 10-year life cycle of Arista shipping its operating system, it's evidenced here in this bar graph very clearly that we're only experiencing a vulnerability once a year in comparison to our competition. Again, this is a testament to how we build our software, how we test it, and this translates into not only high quality for our customers, but a secure operating system as well. And then in ending, these are simply some of the advantages. Many of these are fairly self-explanatory, but a couple that have resonated very well with our customers are our low latency offerings, and in particular, the ability to see buffers in our switches, specifically during times of microburst. Our ability to manage large infrastructures with advanced telemetry using cloud vision, which we'll talk about later. And then the flexibility in design across layer 2 and layer 3 in the leaf spine architecture I mentioned earlier, as well as the ability to upgrade and manage these infrastructures fairly hitlessly with hitless software upgrade capabilities. So these are just a few of the bullet points that we bring to our customers in terms of software and product value. And at this point, I'll turn it over to Judson, who will dive into more of the specifics.
All right. Thank you, Jonathan. Much appreciated. All right. And can everybody see my share correctly? Everybody's okay? Awesome. Well, I would like to dive a little bit deeper into some of the concepts that Jonathan articulated during his earlier conversation. So as we look at the campus specifically, we kind of go into the actual physical topology. One of the things we wanted to articulate to the audience here today is choice, flexibility in how you build out your physical topology in a proven way that we have demonstrated over the last decade plus. So as we look at the architecture, we see it as a collapsed two-tiered architecture based on either a L2, layer 2 leaf spine setup, or a potentially layer 3 leaf spine. It's really entirely up to you as far as providing you that level of uniformity and a level of consistency from a physical topology view as far as patchability, reachability, upgradability, and really trying to do more with less as you look at scaling out your particular campus environment. So as you look at kind of the centralized point of the spine, we actually identified as by the title of a spline. And the reason why we articulate that as such is we view the spine nodes to not only connect down to the individual access closets or leaf nodes, but also allow you to connect individual IoT devices or user devices directly to the spine as well, taking advantage of the PoE capabilities that would reside within certain platforms within our campus portfolio that you may want to architect into your design to support that spine function. Again, layer 2 leaf spine is definitely an alternative for you as well as a all L3 approach. But again, the takeaway here is choice and flexibility as you scale out with uniformity for traffic flows, not only east-west, but also north-south. But then as we move down to the next tier and we focus on the access, we look at when we consider it more of a pod within the access closet. Again, number one, we want to stay standards-based across the board, a very standardized approach where we're focusing on port density at the access layer, as well as performance at the access layer, okay? We want to ensure that as you look at migrating to a, more of a brownfield environment, that if you were to integrate Arista into your access locations, that they would fit seamlessly into whatever existing vendors' products you may already have, okay? One of the keys here is as we look at this particular model is we define two devices within the access closet that we associate into an MLAG pair. And so they're basically virtually a one unit virtually together. And then those MLAG pairs actually provide your uplinks outbound connecting to your spline or spine nodes. And within that MLAG pair, you're going to have survivability and reliability for outbound connectivity. And if you combine that with Anycast VARP, you can actually do single ARP calls to a unified MAC address that's associated with both nodes within the MLAG pair. And also benefit within this pod architecture is the interconnects for the leaf nodes that are connecting to the MLAG pair. This is where you have a choice to define how you want to connect those individual devices and what rates that you think are preferable for the utmost performance. So you can scale those interconnects from 1 gig to multi-gig, 5 gig, 10 gig, 25 gig, and so forth. You can minimize costs by leveraging copper DAC cables versus fiber cables. So again, at that point, you have uber flexibility as far as the type of performance metrics you're looking to achieve, connecting those particular access user-based switches to the actual spine switches. And then traversely, your uplinks can also scale to the higher rates as needed between 25 gig, 50 gig, 100 gig, and potentially beyond. So at the end of the day, the goal here is, from a physical topology perspective, is to provide you ability to create a very small footprint environment, focus on performance and density with choice as far as how you connect things together, okay? And then the last thing is, from a management perspective, being able to build either an L2 or L3 sets of associations with your spine nodes, but really leveraging CloudVision to completely obfuscate the configuration parameters, the deployment parameters. So you're actually making these moves, adds and changes and build outs, either through a zero touch provisioning paradigm or other types of paradigms that truly is built in a GUI based look and feel. So you actually provision these environments in a point and click fashion through the use of CloudVision, excuse me. So as we kind of dig a little bit deeper and you look at the access, you look at kind of technologies of the past and versus what we view as could be beneficial in the future. Obviously, most access classes today are really based on kind of what we call traditional stacking, where you've got a set of devices, there's a stacking bus that connects them all together, and then you have a set of uplinks that go out. Again, sound design, it's been around for years, but one of the things that we think we provide differently with our approach is, one is hitless, non-disruptive expansion of the individual environment within the access closet. As far as bringing in nodes, taking out nodes, connecting devices at higher rates. You may even have situations where you may have an OS mismatch given criticality of getting new devices online quickly. And being able to make those changes and still preserve the integrity of the pod without having a fear of maybe taking the entire stack down when you make those types of moves, adds and changes. Again, highlighted the survivability characteristics of the MLAC pair in respect to providing serviceability out to the rest of the campus. Standards-based approaches. Again, what we're talking about here is nothing that's proprietary at all, as far as how we interconnect the individual leaves within a particular pod to the actual spine, how we provide communications outbound, leveraging underlays that are IP-centric with overlays such as VXLAN, EVPN type services, or just classic L2 services that with .1Q VLAN extensions and et cetera. And again, another thing to keep in mind is growth. And what you've seen in probably older stacking designs is, I may have a certain stacking bus that's limited in bandwidth, and I would have to do potentially leverage forklift upgrades, unfortunately, to change that said bandwidth, or have to do a forklift replacement to achieve those bandwidths that I desire. We believe with our approach as it stands today that I can make those real-time moves and changes. Future-proof is the key here. So as we deal with Murphy's Law and the evolution of data rates over 12 to a 24-month period, I can stay on that curve and make those adjustments at the access closet, not simply based on the evolution of these data rates, but really based on what your user base is asking for and what the network is dictating it needs. And you may have certain closets may look one way, but another closet look another based on the user population that's tied to it. So that's just one thing to keep in mind within those architectures. And also too is the goal here, and I think Jonathan articulated it greatly in the intro here, is we really want to break down those virtual silos as far as application propagation from the client to the cloud. We want to be able to create a unified experience for you. So as you think about providing customers of interest and providing segmentation type services, where you're looking at associating certain wireless SSIDs to VLAN IDs, to potentially VNI IDs, to potentially a set of VRFs at the L2, L3 entry demarcation point, where we really want to make that seamless for you, hopefully in a more point and click manner. So as you continue to segment certain customers of interest, I can extend that segmentation to the far edges of your campus and then be able to create those and maintain those associations throughout the individual, the enterprise in a very uniform and collective manner. So what does that give you? It obviously provides you seamless provisioning services all the way to the edge, the ability to leverage a single set of automation and deployment mechanisms that we'll talk about here later between the individual clients that you service and how you effectively manage your environment from that client all the way through to your data centers and beyond. Again, continue to maintain a standards-based approach with a certain set of IP-based protocols, overlay-based techniques that not only could provide uniformity within your campus proper, but also be able to extend those services outside to branch offices, forwarding operating bases, and other ad hoc campus type services that you may have to deal with on a day-to-day basis. So consistency here is the key. Last point is being able to also extend these type services into the cloud directly. We do recognize that a lot of major agencies out there within the federal community, and maybe even certain specific verticals like medical, law enforcement, et cetera, are now looking to use cloud services quite extensively. And the goal here is not to completely reinvent the wheel when you bring cloud into your enterprise conversation, but to be able to spin up very specific Arista assets within the cloud and provide those same types of reachability services that we're talking about today as respect to the campus. So again, end-to-end fluidity, segmentation, and consistency here is the key. So with that, as we talked a little bit about the architecture, we've talked a little bit about kind of why it makes sense from a configuration uniformity standpoint. Let's talk a little bit about the hardware. So Jonathan mentioned just the evolution of data rates, and Moore's law is really in effect here, where you're looking at this wave that's continually to grow and modify over the years. Merchant silicon is consistently growing faster and at a rate that we hadn't seen prior in respect to proprietary hardware solutions. So we're seeing performance increasing at lower price points. Why is that the case? It's because you're starting to see chip manufacturers building single chip solutions that are just multifaceted, high performing, and has a ton of new and evolving features that fits well into the next generation campus. So what you're going to find is by working with some of the campus portions of our portfolio, you're going to be able to get on that Moore's law curve and take advantage of the evolution of MGig up 2.5, 5 gig services at the access, 10 gig, 25 gig, 50 gig, 100 gig uplink services coming out of your campus devices to other parts of your enterprise, as well as potentially taking advantage down the road of some of your much more larger core implementations around 400 gig. That technology is here today and is available and in fact shipping. So again, the concepts around merchant silicon and why it makes sense holds true today. And being able to take advantage of those characteristics as you look at your next generation campus just makes a lot of sense. And then we kind of couple that with uber flexibility from a transceiver standpoint. Being able to simply put in a new pluggable and go from one data rate to the next without the pain and suffering of forklift upgrades where you're doing numerous rips and replaces just because you want to do a massive migration from a 10 gig environment to a 50 gig environment, or from a 50 gig environment to a 100 gig environment. That really is not the way to go today when it comes to the criticality of environments, the fact that I have to minimize my downtime as I make moves and changes. So simply being able to make a slight configuration change, replace an existing transceiver with a new transceiver, and then take me to that next level of data rate is really where we need to be in supporting our access devices, IoT devices that are connecting to these access closets, as well as providing improved infrastructure from an uplink and downlink perspective as you look at your broader enterprise. So as we look at Arista's campus portfolio, it's listed here. And we actually have wrapped our portfolio around what we call our Trident chipset made by Broadcom. We recommend the aggregation and core, or the spline, around the 7300 X3 modular chassis, as well as the 7050 X3 fixed form factor 1 rack unit, 2 rack unit units that make up kind of the aggregation in the core. Within the access, we have an assortment of 1RU and soon to be modular appliances that now allows you to connect up at 10100, 1000, as well as MGig support, 2.5 gig, 5 gig, with an assortment of uplink options ranging from 1 gig uplinks, 10 gig uplinks, 25 gig uplinks, and For some of the larger units, 100 gig uplinks. And then finally, just really quick, a little bit of an overview of our wireless portfolio. Includes both AC and AX support within these physical access points. And again, we'll elaborate on some of those pieces here later in the document. If you look at our physical wired devices, again, from a 1RU perspective, as I mentioned, one thing we want to provide is choice. And I mentioned that a little bit earlier here, where you may have in a traditional environment where M-Gig is really not a requirement. Well, we understand that. And we actually provide you an assortment of 1RU appliances that are strictly 10, 100, 1000 from a copper perspective with a set of fiber uplinks. Obviously lower cost, fully redundant power, etc. But if you're also looking to move to that next level, we give you an option to move to another set of platforms that are M-Gig related. So that allows you to take advantage of 2.5 gig connectivity, 5 gig connectivity, as well as higher data rates as well. So again, the goal here is to deliver you choice at the access, depending on where you are today and where you would like to be in the future. Okay. We're also introducing, even though it's not available today, we will be introducing a newer unit that's a 2-rack unit access device that supports 96 ports of access connectivity with an assortment of high rate uplinks, 100 gig and 25 gig. Okay. Why we believe this makes sense is for certain access closets where you want to minimize the number of 1-rack unit devices you have in a particular access closet and potentially look at a larger 2-rack unit device to give you that high density, but still maintain that fixed form factor feel. Conversely, this unit makes a lot of sense for those that really don't want to invest in a modular unit because of the number of devices or number of ports required within a particular access closet. So we think this is a very good intermediary between the two individual pillars that I just articulated that really makes it a unique fit for certain customers' environment. So as you think about a 4-rack unit space, putting 2 of these boxes in, and you're dealing with 192 potential user ports with 2 devices, makes a lot of sense for pretty much most access closets out there, in my opinion. This is really a breakdown on power. One of the benefits around Arista's campus portfolio is based on PoE, because we really use a very light amount of power to power basic switching and routing functions. We really only allocate about 200 watts of power for those types of classic switching and routing services. So as you look at our 650, 1050 watt power supplies within our unit, we actually allocate most of the power to the front end ports. So as you start looking at massive number of interfaces with PoE rates at 30 watts plus, you'll definitely be able to do a lot more with the power associations that we have with these units than you may have done in the past. Again, providing an avenue for higher PoE required IoT and access devices moving forward. To date, all of the port products that I just mentioned within our portfolio support 60 watts of power per port. And then you'll be able to select what ports you need to support the certain PoE requirement that you need. Okay. So with that, that was kind of the campus portfolio and kind of what it looks like. I'd like to talk a little bit about wireless and kind of where we fit within that paradigm. But before I kind of deal into the specifics, just kind of talk about the evolution of where wireless has gone over time. Obviously in the past kind of version 1, there was the legacy controller and everything had to flow through the controller from a wireless perspective. APs talked to the controller made traffic decisions on how traffic was propagated from one end of your campus to another. That then transformed into kind of the first generation
0,
cloud.
4, 8, 3, 6.
So then for first generation cloud type implementations, you're taking the controller, moving it into the cloud, and then providing the same type of services, but you're leveraging a cloud construct that had its advantages, it had its deficiencies, but it kind of evolved into that manner. Where we're at right now and where we think we are becoming critical and disruptive within the wireless market is the concepts around cognitive Wi-Fi, where we're taking cloud-based principles and looking at how do we disaggregate the data plane, the management plane, and control plane, and place those individual entities where they can scale efficiently and effectively, but yet providing you choice as far as where those entities reside for the utmost experience for your environment and for your user community. So this is where we start talking about the concepts of cognitive Wi-Fi and what that means to a day-to-day network administrator in respect to network management and moves, adds, and changes, as well as the concepts of security and the concepts of WIPs and how I can integrate that functionality with real-time data propagation, where I may not have to build two separate networks, one for security and one for real data. And then obviously proactive troubleshooting, leveraging the concepts of third-party integrations with APIs, being able to send real-time stream telemetry data to really truly provide benefit to the network administrator as they can understand what's going on, when and how, and be able to address issues as quick as possible. So what are we doing today that we believe is disruptive? Number one, we want to create a secure platform that is pre-built and cloud ready day one. The solutions can be applied on-prem, but you do have the option to take those solutions to the cloud. Also, these environments are secure, they're mature, they've been around a very long time. And again, we want to be able to give you visibility regarding management of anything that is connected to your access environment in your campus. So whether it be IoT devices, sensors, phones, PCs, etc. If there's a device that's connected to your environment through a wireless manner, you should have visibility to it and be able to understand the quality of the experience originating from those individual clients. Number two, we've integrated a set of AI components or ML components within our overall structure and model. So as we look at telemetry data coming from your wireless environment, be able to apply an AI construct against that data, and then be able to give you a set of metrics of what's going on, when and how. Third-party radio, again, being able to integrate a security paradigm along with data flow. And then again, I mentioned the API integration for third-party service integration in a standardized way. Here is a view of our individual access points. We'll talk a little bit more about them. Again, we have AX support, Wi-Fi 6, as well as AC support within our portfolio with Wi-Fi 5. Again, structures of the access point. The one here I want to highlight here is the third radio. So again, being able to leverage that third radio for client emulation services, resource management, spectrum analyzers. So a lot of the analytical tools that you may use have to bring in as a third party, we've actually integrated those type of services with the use of our third radio. And again, as we look at the past, and which we're really looking to evolve away from, where you're looking at the controller as kind of the center of the universe, as far as controlling where data flows into and where it flows out of. And as you can imagine, when you have multiple communities of interest and multiple sets of requirements tied to those individual user communities, the path that the controller may dictate may not be the most efficient path. So you need to really have uber flexibility within your next-gen wireless environment to really decouple kind of that control plane function from that data plane function, as well as from that management plane function. So this is where our solution comes into play, where we have a controller-less environment within our our wireless solution set. Number two, the data plane grows as you add more APs within your environment, okay? So the data plane scales as APs are added. The management plane is completely disaggregated. That management plane can reside on-prem, or it can also reside in the cloud. And then the control plane is also disaggregated. So as I continue to scale out my wireless environment, I will continue to grow and evolve my control plane as well as my data plane. And then I can strategically place my management plane where it makes sense within my environment. I can extend VXLAN and Ethernet over GRE type services all the way to the access point. So again, I can provide that segmentation from wired to wireless in a seamless manner. And then I can also, I don't get burdened by the control tax of the controller. Since that controller is no longer there, there's no independence there. So I can then move on and really scale out in a very uniform way. And this is a representation of that, of what I just articulated between this decoupling the data plane, control plane, and the management plane, and how that will then integrate not only into the wired environment with the portfolio that I just mentioned, but also local SIM tools, and security tools that may be receiving data from the access points for real-time analysis and modifications. Okay, so from a configuration standpoint, why do we believe we are disruptive here? One is being able to provide you as the administrator the ability to see more than just simply the network portion of your wireless environment. Because in many cases, the issue that may be causing disruption to your user community may not be related to the network. It may be related to an association and how the clients are getting on board, or an authentication issue that may be occurring, or an application may be misbehaving. And as a network operator, I need to be able to have visibility at some of those other levels outside of just the network. Because from my view, if I'm just looking at the network, everything looks fine. But in reality, there's other variables in play, and we want to provide you visibility to some degree with those other variables. So with that, we've defined within our management construct the concept of the client journey. Being able to define the journey from that individual client coming online and the type of applications and sessions that that client is generating onto your wireless network, into your wired environment, and be able to attract those associations, okay? And how do we do that? Well, we created this concept called QoE, the quality of experience. And it really resides, and it's that quality of experience is from the user's perspective. So as you take a client or a cell phone, what do is we track all the sessions associated with that particular client. And we take a trace of those sessions. We take a sample of all of those sessions, and we actually push that data or stream it to our management plane that then gets analyzed against our ML and AI functionality. And really what that does then starts to create a model for you to then give you an experience of, from an application level, of how that session is being viewed, or how well or how bad it is at the application level. So as you look at aggregating all of this content through this QoE process, you're now given a view where you as an operator can look at the experience application by application and really get an idea of exactly what the overall experiences are and where are the deficiencies are and where they reside. And to be able to dive into them real time as you look at the overall enterprise-wide QoE. This was a big deal for Arista. It really opened the minds as really bridging that management gap between wireless and wired. We're in the process now of including other applications that are more focused around distance learning, given where we are today and the situation we are in the world today. So you'll see additional capabilities through this QoE process in respect to Zoom and other distance learning type of applications, and giving you those views from the client's perspective. So outside of data propagation, also I'd like to dive a little bit into WIPs, okay? Because again, we have an integrated WIPs capability within each access point that we offer. And why is it important? Number one, we have the ability to identify every type of attack, which is very unique in the marketplace. Other vendors have the ability to see certain types of attacks, but some other attacks they can't. We believe we can view a lot more than maybe some of our competitors can do today. So being able to identify the attacks and then be able to address them immediately and articulate to you those attacks visually. Again, these platforms are fully certified, but one of the certifications that makes the most impact for me is the SOC 2 Type 2 certification. Why is that important? Because that certification is tied to how well we protect the data that we collect and how safe and protected that data is. And we think in today's world, that is a big deal. And so being able to collect that data in a way that's been accredited and certified, we believe we're one of the very few solutions on the market today that is in fact SOC 2 Type 2 certified. So if security is important to you and how that data is secured and effectively maintained, I think I urge you to take a look at our platforms from a wireless perspective. You'll be pleasantly surprised. And then the last thing too is how we approach looking at attacks and exploits and signatures and vulnerabilities. We believe a majority of the solutions in the market have a more of a WIDS type approach versus a WIPS type approach, where from a WIDS approach, you're kind of more in a cat and mouse game, where you're chasing exploits and signatures real time, and you're making patches to them real time, etc. But we think that process is very inefficient. We believe that our WIPS approach, where we're looking at the building blocks of the attack itself, not the overall attack, but what are the core building blocks that make up that attack? And it's those pieces that we focus our WIBS services against. So by doing that, we'd be able to kind of catch it at the foundation and break that foundation down to completely obliterate some of these individual exploits from the ground up. And to do that, we've actually developed a sample of techniques. One is related to the concept of marker packets and reverse marker packets that we send on the wired side and the wireless side, to basically to look for rogue APs and rogue clients and rogue devices through these marker packets, to allow us to get a visualization of the environment and to provide not only identification of those particular rogues, but to attack those rogues as well, as far as jamming them and preventing them from tapping into your environment. So real quick on the Wi-Fi front, Wi-Fi 6 front, I just want to articulate a couple things. Again, AX is here. We're still building up around AX and Wi-Fi 6, but just a couple takeaways. Number one is the evolution of AX is really focused on performance, and performance as it relates to high density areas. From the foundational standpoint, AX is very similar to AC. But again, when you start looking at high density environments and really ranching up the performance in those environments, that is where AX is going to shine moving forward. And again, as we look at some of the characteristics of the AX, these are just some of the characteristics that helps make that high performance paradigm happen between OFDMA versus OFDM, higher performance through a more granular modularity, multi-unit MIMO, 8x8 up and down comes into play, spatial coloring, where I can modify the PHY header of a wireless AX packet to provide a certain color between one or the other. Again, a higher QAM, again, a more efficient modularity, and then also the ability to support a 2.4 gigahertz spectrum as well as a 5 gigahertz spectrum within an AX access point. Here's just a breakout between AC and AX. Again, probably the biggest takeaways here is being able to leverage not only the 2.4 spectrum as well as the 5 gigahertz spectrum. It makes AX very attractive, as well as the theoretical data rates that we believe we'll be able to achieve with the AX standard. As I mentioned, a multi-user MIMO is coming. We're really waiting on the client side. As we start dealing with dual radios and dual connectivity, multi-radio connections at the client side, you'll see multi-use MIMO start to evolve. The APs, the AX standard is ready. We'll see what happens as the client side starts to grow. BSS coloring, again, that gets into, I'm in a high density environment. I've got a lot of devices communicating, and in some cases they are stepping on each other because of conflicts. With BSS coloring, we're now adding a header to the packet, to the AX packet for each individual client that identifies that client for color red or color blue or color green. And by doing that, that then allows that client to only pay attention to traffic associated with its color. It completely ignores other adjacent noise in that respect. So you're not seeing as many collisions and contention and backoffs within a very high density wireless environment. And then another really cool feature with AX is target wait time, where now you're looking at being able to make your, being very efficient when it comes to operating certain client devices, where you have clients go to sleep, wake up, transmit traffic, and then go back to sleep. So you're not having these radios and antennas constantly on, sending and retrieving data. So you're now dealing with uber efficiency as far as power and consumption of power is concerned. And number two is being able to minimize those contentious, dense environments regarding collisions and contention between clients. So When clients are asleep, they're not transmitting. That allows us to focus on other set of clients to transmit, and then we change that paradigm where then after transmission, they go to sleep, then the other clients wake up, etc. Again, minimizing the amount of data flow across the air. So again, things to consider. Again, there's a lot of really cool things going on with AX right now. Our access points are purpose-built and ready to support AX today. I mentioned some of the features that made AX a pretty cool solution to solve very short-term problems. Again, we're still got to let the client world catch up a little bit around AX. But again, as you're thinking about the future of your wireless environment and where you want to be, I urge you to consider AX as a potential platform you want to step into. It has backwards compatibility to AC, so there's no worries there. And again, please allow us from an engineering standpoint at Arista to help you as far as identifying those structures and helping you with some of those designs around the wireless world. So in summary, closing thoughts, just wrapping everything all together when it comes to our campus portfolio. What are we trying to do? We want to minimize your overall CapEx across the board from wireless to wired, leveraging merchant silicon so you can ride Moore's law for those higher density data rates that are coming out, being able to make the migration to those higher rates as simple as putting in a new transceiver and taking the old one out. Leveraging the Wi-Fi technologies that are now coming together today so you can adjust your present to define your future. Creating an architecture that's uniformed, two-tiered, a spline and a leaf type of construct. So you have uniform reachability not only from north-south, but also east-west. Operational benefits by flattening that architecture, I'm simplifying it and I'm applying software to provide individual segmentation services as needed. Taking advantage of our extensible operating system that was predicated on quality from day one, coupled with reliability and consistency. Leveraging the wireless side of the house and the quality of experience, and leveraging some of our AI and ML capabilities to apply against that data to make preventive decisions and be more proactive versus reactive. Then obviously security is a big deal, and being able to create a standards-based secure paradigm at the wireless areas of your environment, as well as your core wired campus as well. Again, providing a cognitive approach across the entire construct, both from a data plane perspective, control plane perspective, and a management perspective. So with that, I'd like to just pause and take a break. I'd also like to pose some questions. I know you've heard a lot from myself and Jonathan over the last hour or so, and would like you to post the questions as we kind of exhale and transition to the next presentation. You'll have about a minute to answer these questions, and then we will go from there. So if you could post the questions, please.
Judson, do you see the first question? Does security segmentation is applicable for wired traffic or both wired and wireless too?
I'm not seeing that question, Jonathan.
It pops up in my view. In essence, it's basically a question asking, does security segmentation apply to both wired and wireless traffic?
Judson, it's in the QA section at the bottom of the screen. You look into open questions, it'll be there. We've been answering them along the way.
Okay. Let me go ahead and stop my share, guys, so Adam can jump on.
Yeah, I don't know who sent that, but we'll talk about this a little bit in the Cloud Vision section, but we have, and also with Forescout when they get on, but you'll definitely have ways to manage security segmentation, whether that be from micro or macro perspective with Cloud Vision. For wireless and wired.
All right. Okay. Do we want to go ahead and move forward now, everyone, before we move to the next section to kind of talk about the questions and answers? All right. So to review the questions. Again, I appreciate all those who decided to participate. Thank you so much. So question 1, what is the maximum amount of PoE power provided by Arista's campus products? That answer is 60 watts of power per port. Number 2, how many radios within Arista's C-260 access point? And the answer is 3 radios. So again, we provide 3 radios within a majority of our AC and AX access points. One is for a WIPS scenario. Obviously, the other 2 radios are providing transmission of real customer traffic. Number 3, how many user ports are available within Arista's largest fixed form factor campus switch? That answer is 96 ports, 2-rack unit, 96 port device. That is correct. The answer there. Number 4, what year did Arista introduce the first 400 gig chip with VOQ fabric to the market? That answer is 2019. Again, as we look at Moore's Law, the fact that we are now in the world of 400 gig is quite amazing to me and exciting and all at the same time. So I'm really looking forward to where that goes. And then finally, number 5, true or false? Software quality is not the most important attribute in respect to Arista's products. That answer is false. All right, quality is in fact the most important thing from Arista's standpoint in regards to our extensible operating system. And that is really the foundational element has led to Arista's success to date. So again, I'd like to thank everybody for taking a stab at those questions. I'm glad you guys are still with us. And with that, I'd like to hand this over to Adam with Forescout to talk a little bit about Forescout and Arista as we look at collaborating together around the future of network security. Adam, take it away.
Excellent. Thank you, Justin. Appreciate it. Hello, everyone. My name is Adam Kohler, and I'm a SE manager out of the Northeast with Forescout, and I've been here for about 6 years now. So I just want to talk a little bit about how Forescout is addressing both the visibility and control gaps that we see in our customers and in the market. So as you know, of course, lots and lots of more devices are connecting to the network. A lot of them are headless, unmanaged devices, IoT, or even OT-based ones, such as your HVAC or power-based, devices. So WannaCry is something a lot of people are talking about, but as of most recently, and NotPetya, but as of most recently, we're helping our customers on a day-to-day battle with the new recent outbreak of Maze. So we have an ever-increasing attack surface that's very hard to secure via traditional methods, such as authentication and/or agents. So some of the challenges that we're seeing is, obviously the explosive growth of IoT devices, as well as the convergence of OT devices and IT networks. So a lot of times in our customers, those responsibilities are now rolling up to the same CIO that traditionally and CISO that traditionally managed the IT network. Now they're dealing with a lot of OT and IoT-based devices on their network. These devices are creating additional attack vectors. They cannot be secured by authentication methods such as 802.1x. And as I mentioned, it's rolling up to the same budget and the same C-level executives. In addition, some network complexity is also making them a bit harder to secure, maybe through M&A activity or just older, outdated gear that you haven't replaced with the new, latest and greatest Arista stuff. You are, having issues with actually supporting that. And so across the board, Forescout is able to support many, many different types of vendors. Now, we also want to do, talk about a little bit about malware prevention and containment. So especially when we're talking about threats such as ransomware, it's very, very important to rapidly contain those types of threats. So a little bit about why Forescout. So the Forescout platform is divided up into iSight, iSegment, iControl, and iExtend. We first and foremost want to identify the devices that are connecting on your network, and we're going to use iSight to do that. We're going to profile those in a multitude of active and passive ways, everything from listening to traffic to actually scanning the endpoint and doing active probing. iSegment allows us to take those contextual groupings we create in iSight for the different types of devices, which could be based on anything from a user to a cyber hygiene or an application that's installed, and allow us to analyze traffic flows between those devices. So we can put segmentation into business terms and allows us to also test controls. So what if scenarios, if I had implemented this ACL on my Arista switch or changed this VLAN, et cetera, what would have been impacted, what traffic would have been blocked. We have iControl, which allows us to actually implement those controls. So doing a switch block or a VLAN or ACL assignment on your Arista infrastructure, for example. And then iExtend allows us to get multi-contextual information from a lot of different types of tools that you probably already have in your environment, whether that's sharing information for a SIM or allowing your SOC analyst to kick off actions in ForeScout without having to know our platform, or maybe it's sharing our information with VA tools, as well as getting threat information from your APT tools. We're going to do this natively across your cloud, data center, campus, IoT, and OT environments. And we also made an acquisition a little bit over a year ago of a company called Security Matters. They have a product in silent defense. They're very popular in the ICS space. They allow you to actually passively monitor OT devices, understand even serial devices connected to IPs, as well as what firmware and vulnerabilities are associated with those devices. So device visibility and control. So first and foremost, how we take a bit of a different approach is we allow you to know what's on your network first. A lot of traditional control vendors will ask you to do authentication first, so they lead with authentication. Whether we're talking about traditional network access control or the next evolution of access control, which is really network segmentation, we let you start with visibility first to understand what would the impact be if you take those controls. We want to understand the IoT and OT devices and what risks they're bringing to your environment, the traffic patterns that those devices are communicating on, and then help you to enforce and automate those controls while orchestrating workflows with a lot of the cyber tools that you purchased and are operating in your environment today. So ForeScout, core differentiators and something that is core to our blood and our DNA is we want to be agentless. We don't ever want to force you to have to install an agent on an endpoint to understand what's going on. We want to be heterogeneous. We want you to avoid vendor lock-in. So if you want to have Palo Alto's as your firewall vendor today and Checkpoint or Fortinet tomorrow, and you want to have Arista as your switching integrator, we're going to support all of those leading vendors. And then we also do a lot with orchestration. And a lot of vendors talk about orchestration, but it's typically, here's our API, good luck, and have fun supporting that from version to version. When ForeScout talks about orchestration, these are actually core developments that we've made with our business partners through strategic alliances such as we have with Arista, where our development teams work together and we support them from version to version. So a little bit about how Arista and ForeScout are better together. So ForeScout's going to help you discover and auto-classify any device that's connecting to your wired and wireless networks. We're going to let you know what function, the OS, the vendor, the specific model, and we're going to do all of this in real time without ever requiring agents. We're going to assess whether or not that device has vulnerabilities, if it's not compliant, maybe it's a non-corporate device. And based on the policies you define in ForeScout, we can trigger auto remediation. We can limit the network access by enforcing network access controls such as VLAN or COA if .1x authentications are supported on that device, or a switch block. And we can do this all leveraging natively on the Arista network infrastructure. So just a little bit of a summary, Arista's open ecosystem is going to allow us to integrate with them using the EOS platform. We're going to use standard protocols like SSH and SNMP. We're also developing integrations with their CloudVision platform, which are going to be API driven. So this is going to give you enhanced visibility into the type of device that's connecting, as well as the ownership and the hygiene of that device. Allows you to detect threats quicker, as well as actually respond to them. So if we need to stop that device from propagating malware east to west on a campus switch, as we've spoken a lot about, ForeScout's going to be able to react to that in real time and tell Arista to block that device. We're also going to enable dynamic segmentation based on your business needs. So through iSegment, we can map those logical traffic flows, show you what's happening today, and as your business changes, show you what's continuing to happen to allow you to adopt your segmentation policies. And then we're always there to watch, continuously doing our policy enforcement automatically using our policy engine. So if you'd like to learn more about the ForeScout and Arista integration, as well as the future of network performance and management efficiency, you can register today for one of our webinars that we have coming up on May 20th at 8 a.m. Thank you all. Appreciate your time.
Hey, thanks, Adam. Let me see if I can share my screen here. Can you guys see that? Can you hear me okay?
Can hear you loud and clear, and I can see your screen.
You're just fine.
All right, awesome. Thank you. So with Cloud Vision, we're going to talk about cognitive automation. I know Judson and some of the others have already kind of mentioned Cloud Vision. We're going to dig a little bit deeper on the workflow and walk you through what that would look like from an operational perspective, from an automation orchestration perspective. As I was picking a shirt this morning, I actually passed by one that was from a Cloud Builders from 2016, which was 4 years ago when we were demoing some of this Cloud Vision stuff back then for our customers. And some of our top tier SPs actually ended up deploying and deploying data centers with hundreds of devices. And today they're managing campuses and data centers with thousands of devices. So this is a serious, we've invested quite a bit into Cloud Vision. It's scaled out quite a bit, so it's definitely ready. And we're going to talk about a lot of the features for that today. So, as network engineers, we've always kind of focused a lot on data plane, control plane, what that's looked like, and management sometimes takes a backseat. But as we know today in the environment, it's just as critical, if not more critical than ever before. So what we're trying to do here with Cloud Vision is provide you guys a cohesive and comprehensive solution, right? So something that from a comprehensive perspective provides you all the feature, the functionality that you need to support your networks, and from a cohesive perspective, supporting all the different deployments that you have, right? Whether that be wireless, wired, container, virtual infrastructure, all of those could be managed from a central point of management in Cloud Vision. And as we talked about earlier, we have a strong focus, and the messaging's been the same, right? Ever since when we originally did these presentations, it's all open standards based. We focus on quality first, single EOS, right? So even with our telemetry streaming, there's no lock-in here. This is gRPC stream from state stream from our devices. From a southbound perspective, we're connecting into the API of the devices. From a northbound perspective, you can connect into the various services with the REST API. So you could turn up Cloud Vision today, and if whatever there's no particular devices that were locked in, you could turn it down tomorrow if you need it. We don't provide any kind of additional software that makes that those streaming and features work. We don't lock you into particular hardware platforms. This is a completely agnostic solution that works across the board for all of our infrastructure and all of our services. So we're going to walk through some various parts today. I'm going to try to keep it pretty interesting. We're going to get some videos in here. We'll start with provisioning, and we'll talk about compliance, some of the custom dashboards you can do, as well as security, visibility from a topology perspective. We'll talk about some overlays with that, and then we'll wrap up with some wireless as well. So starting with provisioning, what you're going to see here is we have this hierarchical structure. So we had some questions earlier asking about, how do we manage wired, wireless, and there's a lot of questions, actually several questions we had around managing the MLAG environment, managing devices. How would we do that from a central point of management? And this is what this is. It's a hierarchical way for you to structure your network, put your devices into what we call containers, which I'll show you in a video here in a second, that the devices within those containers will inherit a particular configuration. Those configurations and little snippets down here we call configlets are basically your templates, right? So it might be an ACL, it might be some base configuration, anything that might be specific or not specific to that device. So in this video, we're going to walk through a few of those things that I just mentioned. These are I'll pause it here. This is the container structure. And this is not to be confused with a topology view. This is a hierarchical manner of how we structure your template and your configuration, right? So in this example, we only have a single device per bucket, but you could have many, many devices in each of these buckets, right? Let's say you had a data center with 200 devices, right? 100 of those devices are in the leaf bucket, and anything that's applied from a configuration or a template perspective or anything that's specific to those particular devices or common, you can apply at that container level. If it's image, configuration, that all gets inherited. The higher up you go in this structure, the more inheritance you have, right? So if I have a base configuration that I want to apply, let's say we're setting up the MLAG environment that Justin demoed earlier, right? I might have all these devices under one single bucket and have a common configuration between those devices that I push out. So as we walk through here, what we're highlighting here, you see a device in yellow. This is actually part of our compliance that we'll talk about a little bit later. where it highlights devices that don't conform with the template that you've subscribed. So on the left here, you're going to see what we call the configurates, and those configurates are the pieces of configuration that we were talking about. And on the right, he actually clicked the reconcile button here, but what that means is a piece of configuration that doesn't conform with what you've designed. Okay, so when we look at a device in CloudVision, we combine all of these templates and configurations that you've created into what's called a design configuration. And that's what you see in the middle. So the design configuration is what we want on the devices. On the right, the running configuration is what's running in real time on the device. So if I scroll back a little bit here, you'll see that they pulled up a particular configuration, VLAN 100. VLAN 100 may have been added by some other user, but for whatever reason, that doesn't match with what our templated config is. So this is a great way to find configuration errors. Maybe someone left it in from a maintenance, whatever that might be. So once you've identified the configuration that might be anomalous, you can actually save this configuration here and create a task, which we'll walk through a little bit later, to update that configuration. So even with your current scripting and workflows that you have, the idea is, with CloudVision is we want to enhance those. We don't want to lock you into a particular method or change your workflow in any way. The idea is to enhance. So this flexibility with configlet builders is what we call them, where you can put in any custom scripts you might be using today to configure your environment, or any kind of GitHub. Actually, you have GitHub repositories. You can create form submissions that create configuration based off your current workflows. So you could, for instance, if you configure a particular VLAN and you want to add an IP address, you could create a form for the user just to input the IP address, and then it will create, based off your template, what your standard configuration is based off the inputs that the user put in. You can take this a step further, and we've done this quite a bit with some of our other customers and professional services. You can hire them as well, where you can create a Python script or other scripts that can basically automate from your existing tools, plug into your existing tools, and generate configuration dynamically per device. So the change management tool, this is basically, I don't know if you guys have worked with MOPS, but MOPS, method of procedure documents, this is basically what this is. It's an automated way for you to do your change controls. So you can actually structure this in a way where these tasks that we've created earlier for configuration, image upgrades, whatever you might be managing at the time, you can operate them serially or in parallel with one another. And when you execute those tasks, you'll actually see them run in real time. You can add custom scripts. Let's say, for instance, that you want to add, maybe you want to turn down some interfaces that are on particular devices so that those hosts don't get affected, or whatever it is you might want to add in the middle of these steps, you can do that as well. So in this video, what they're doing is basically pooling, I'll pause here for a second. These are tasks that get generated in CloudVision when you execute something. Like so earlier, when we identified that rogue or the anomalous configuration, we could have saved that task, and that task would show up here in this panel. As you generate tasks, those tasks can be assigned to the change control, and the change control can then be scheduled. And we'll walk through a couple of steps there about how he's doing that. The first thing he's selecting is a few spine devices, and those spine devices have been tagged for EOS upgrade. So maybe I right-click those in my topology view. I've said, hey, I want to put a new EOS on these devices. And what we're doing now is saying, I want these all to run serially. So each device will be upgraded one after the other. He's also adding a couple actions in here where he's asking to do a BGP maintenance mode. So he went in here on the right and selected a couple of tasks to run in conjunction with the EOS upgrade. And as he pulls more devices, you can see he's pouring in the leafs. And the way you can kind of customize this, it's all click and drag. You can take the task and execute those in parallel and serially. So in this instance, we're actually taking some of the leaf devices, and the A side, we're going to execute all at once, and the B side will execute all at once. So after we added those particular steps, you can also add in a few other things and stages, right, and give names to those stages. So for this particular stage, it's a leaf upgrade, we have a spine upgrade, we're going to add some more actions. Maybe we want to do some snapshots or health checks. So in this particular example, they're adding some snapshots in here to take a pre-check of the devices that we can reference in case there's an issue to roll back to. And once you execute these change controls, you can also, roll back as well. Now what he's doing now is he's actually reviewing the changes that we've made. So in this step, you can go through and look at what you're changing and what, like for instance, they're upgrading, you can see from 418 to 421, what the steps are. And once you've reviewed it, you approve it, and now he's executing. Now this obviously is going to go very fast. This is virtual instances, so it's almost immediate. But as you're doing this on wired devices or wireless devices in real time, you'll see that this will, as soon as these particular actions are complete, it'll move on to the next one and check it. So these are, if you remember earlier, these are the ones that we set up to execute in serially. And then we'll move to leaf upgrades where we execute them parallel and serially. So leaf A's, so all the A sides begin the upgrade. Once they're complete, then we execute the next step, so on and so forth. And at the end, he's actually doing a Slack notification where he's sending out a Slack notification that says, hey, these devices have been upgraded. So beyond that, a couple other things from provisioning I wanted to highlight. Continuous snapshots. So this is a dashboard-like health feature where you can drill down into the devices and it'll show over time what the health of that particular device. So for instance, you might be looking at configurations, which you can compare and contrast over time. You can look at version changes, CPU load, hardware table utilization, and we'll get into this in a second. You can actually look at the bug scrub or the bugs that are applicable to that device as well. So within CloudVision, since we're getting all of that data already for the version, we're getting the configuration, we're getting all the stats for that device, you can upload our bug database, which will then respond on tags for those devices and give you a report on known bugs in real time. So once you put the database on, we'll be able to drill down to these devices, show an exposure list to see what bugs you're exposed to, and then give you input on those bugs as well. So this is a very powerful tool, and a lot of customers use this. Cool, so that was a quick highlight of the provisioning aspect. Now we want to get into some of the telemetry tools as well. So the legacy approach to telemetry has really traditionally been SNMP polling based, and we're getting better and faster with that. And now with CloudVision, we're able to do real-time streaming over gRPC, right? No longer do we have to wait on those intervals with SNMP where we can miss particular events. And commonly what I've seen, and a lot of people, a lot of customers have asked me about this, microbursts. Jonathan kind of alluded to this earlier as a common problem, and that's very easy to miss in our traditional polled state. But with real-time streaming and LANs, which we'll walk through in a second, you can actually see in real time your buffer utilization to capture things like microbursts or other things that traditionally just would not be able to be shown with SNMP and other tools. So what this slide highlights is that with CloudVision, when we built CloudVision, this is our emphasis on openness, right? We are not trying to provide some kind of lock-in. We built this tool with common elements that are out there today, HBase, Kafka, right? We did pull in a couple, not proprietary, but some implementations for turbines for the analytics pipeline. But all of these things is, if you had the resources, you could build this today. We're not locking you in any particular manner. If you were to build this, right, these common elements like Kafka, HBase, from a visualization perspective, Kibana and Grafana, we've done all the work for you, right? We have an army of software engineers that are invested heavily in this product that have provided all the analytics and telemetry visualization for you in this turnkey solution. So as an overview of how this works, I talked about this briefly earlier, but from a southbound perspective, as far as the provisioning, we connect into the eAPI of the device just to pass some of the commands and some of the data gathering. From a telemetry streaming perspective, we're using gRPC. From a northbound perspective, we have a RESTful API that other devices and vendors can plug into. The data comes into the ingest gateway, we send it to Kafka, we store it in HBase, and then we have a process called turbines where we do the visualization and all the analytics of the data that we've grabbed. This is a picture of the dashboards you can create for the real world metrics, and I'll pull over and show you a little bit more about this in a second. But this is more of a way for you to create a custom dashboard of the metrics that you're interested in. So in this particular scenario, in this example, we're pulling in output power, port state, and some of the devices that are listed in this particular campus. And we're looking at what the utilization is over time, right? So you can definitely cater this to what's interesting to you, right? For other examples, you could pull in CPU utilization, you can pull in bandwidth utilization, what's the version on your devices, right? This can be completely catered to the metrics that you're interested in for your network. And actually, if I could pull it over here, let's see if you guys can see this. You guys see this screen?
Yes, sir.
Okay, cool. So this is actually, I wanted to show you this because I think it's really interesting. This is a live lab environment that I have, that I've built some kind of custom dashboards just briefly to show you how this works. So when I click on the metrics tab here, I have the option to either select some of my own metrics that I may want to just group metrics by, or devices, or I can create the custom dashboards as I was saying earlier, right? So this one I've just created just to show you kind of a live state and really highlight what I mean by real time, right? This is not like sub-second green light, stop light stuff. If I go down to 30 seconds, you can see this is updating on a per second basis. I mean, this is really powerful stuff. We're upgrading or uploading this stuff immediately to CVP and visualizing this. So I can take this time variable and drag this over time. I can show it live. I can show a 5-minute, hour interval. I can drill down into where I see specific spikes. Like here's a CPU utilization on this device where I see specific spikes, right? So I can lock into those spikes and actually drill down into processes and other things that are going on with that device. And again, I could add something else to this view, right? This is a custom dashboard that I built. I could add, maybe I'm interested, okay, I see a CPU spike utilization. What was going on in that device at that time, right? If I select a device and I select a particular metric, maybe I want to look at the total route count, and I can look, okay, maybe there was a small route jump I can see between 84 to 100 routes that correlates in time with that CPU utilization, right? So this gives you this, from an operational perspective, the visibility and the granularity that maybe you weren't getting with previous tools to show and correlate CPU with other metrics in real time, right? And it doesn't end there. There's quite a bit of metrics here that we can pull in. And, you know, if it's not here, in my experience, it's been very easy to implement additional metrics if you work with us or something that's important to you. Cool. So that's the metric dashboard. Here's a couple of use cases I wanted to highlight from other customers that I thought were very powerful. Here's one from a customer where they had an event that was generated where it said that we had a utilization that crossed 90% for the routing table. This actually allowed them, after realizing that they misconfigured the device or didn't include in the template the correct routing configuration, to go in and fix this before it was a problem, right? So this gives you the ability to proactively fix your network rather than reactively. And that's really the power of a CloudVision, right? And the cognitive side of CloudVision is now we can react on, instead of reacting on events, we can proactively fix them before there's a problem. So in this particular view here, this is called the events page. And what we're doing is we're streaming all of the syslogs in real time to this device. And then we give you recommended, correlated statistics and recommended action that you could take, right? So for instance, we're saying routing table exceeded, and then showing the total utilization right now on your device, right? So then you can take a smarter approach to how to solve that. So this is one other feature I mentioned earlier with LANs. LAN stands for Latency Analyzer, and that's our buffer measurement or buffer analyzing tool, right? So when you see a burst or a microburst, LAN is able to capture that buffer utilization on a sub-second and microsecond level. When that happens, you'll actually generate a log that says, for instance, queue size above threshold. Even if that's a microsecond, we will generate a log. That log can be sent to CVP, And with CVP, when you look at that particular log entry, we can pull up statistics and visualize what's going on in the network at that time. For instance, traffic rate. So we can see at this particular instance for this congestion event, there was an increase in traffic rate on this particular interface at this time, right? So now we can say if an application owner comes to you and says, hey, we're seeing some issues with application disconnects, what's going on? If you can correlate that time, as we were showing you earlier with the time slider, you can see what's going on from a buffer utilization standpoint, from a traffic output standpoint, and becomes very powerful from a mean time to innocence perspective. Even if there's not an issue, right? The application teams come to you and say, hey, what's going on with the network? You can come back and say, well, look, I've looked at all the stats in our network at the time that you said we didn't see any sort of congestion from a buffer perspective. We didn't see any output discards, et cetera, right? So that gives you the tools that you need to prove out that this is not a network issue. So topology viewer is the last section here up top that we're going to show for as far as telemetry. The topology section shows in a hierarchical way your network. I mean, it's all LLDP based. So all the devices here are basically displayed based off the LLDP table. And we can actually drill down and look at those particular devices and add overlays, which we're going to show here in a video. So in this video, what they're showing is basically all of the devices you've added to CVP and all of the devices that those devices can see via LLDP, right? So in these particular racks, we can actually expand out. And even though that these servers aren't in CVP, they are running LLDP, so we can visualize what that would look like in your network. Now, as we go on, you'll see that they're going to add in a few overlays here, like the bandwidth utilization, where we can see in real time the streaming utilization of those interfaces and what's being used, right? So all of this data is being streamed via the Terminator agent that we're running on all of our devices by default. Once you enable that, we're streaming in real time to CVP to have them visualize. Now, the next part he's going to dig into, which I think is really valuable, is showing discards and errors, right? So how do you track down discards and errors in your network with these overlays? Discards, it just pulls in the same data that we're already streaming, right? And then overlays that on top of the information I'm getting via LLDP connected to our devices. So if you look at this particular instance and where they're clicking, you can see that there are certainly some links on this network that are having errors and discards that need to be troubleshooted, right? So now you can identify to what host, in particular, this particular access point, which is passing traffic, is seeing errors and discards, and then troubleshoot that. So to wrap up the telemetry section, there's a few other things that we're working on that are very powerful. One is the flow tracker, which we're basically an SLO collector and able to report back on top talkers and other flows and data points in the network. We can also report on the device analyzer, which shows you different endpoints in the network and areas in the network where you might have particular devices that are talking with one another. We'll show you the flows for that. We'll show you the operating system, what device that is, to give you an idea and a holistic view of what is connected to your wired and wireless network. Cool, so that's the provisioning side. We've went over the provisioning, the telemetry. Now we're going to get into some of the Wi-Fi. So as Justin and some of the other guys have alluded earlier, the idea here is we're providing a solution with CloudVision that is comprehensive and cohesive, meaning that it still involves wireless, wired, and we're going to show a video that displays that all together in one single management point, right? No longer do you have to worry about utilizing different tools for different platforms or conjunction with other tools that you might be using today. It's all a single platform that manages wired, wireless, containerized, and virtual infrastructure. We touched on this briefly, but a few of the things that we're able to do, which is pretty powerful, is provide the client journey, right? So from a client perspective, what are they seeing? Are they healthy? Are they not healthy? Are they able to connect? So these dashboards in the wireless section give you an idea of how healthy your network is from a client perspective, from an application perspective, from a WIPS perspective. So what the client journey shows you is association issues, authentication issues, network issues, and then drills down into what caused those particular issues. As we get into the applications, you can see that from a monitoring perspective, we can actually click on certain applications, see what the health of those are, see which users are using them. We can drill down into what's causing the unhealthiness of those particular applications and then do an automated root cause. So this is really where the cognitive comes into play, right? This is where, okay, we've got the data, we've presented you with visualization on what's going on. Now, what do we do with it? Right? That's the part that's been the most challenging, I think, for everyone, right? Like if we have the data, what do we do with it? And this is what that is, automated root cause analysis. So now we're able to provide you guys with a solution, right? So you have a particular problem, what is causing that problem, and then a recommended solution of how you can solve that problem. Not only that, but we also, when we identify an error, we actually create packet captures that are visualized in the tool as well. So you can drill down into a particular area, view a packet capture, and see what was traversing or what was going on, whether it's an association failure, authentication failure, and see what packets were traversing the network at that time. And then where the machine learning and the cognitive comes into play is baselining, right? So after we've created a baseline after so many days, months, over time, we know what particular events are out of scope, right? And when they're out of scope, then we identify those as issues and beyond the baseline. And then when you're beyond the baseline, that's when you know you've had an issue and you have to take action on it. So in this video, we're kind of starting from from some of the wired devices that we have here, and then we're going to drill down into the AP. So this is kind of like the summation of everything we've sort of been talking about, right? We start with some of the devices that we have, maybe from a wired perspective, and we're showing what the models are. This is the device panel showing what IP addresses and MAC addresses they are. Then we get into the connected endpoints that we mentioned earlier, where we're showing what are all the devices that are connected in your wired and wireless platform from a fingerprinting perspective. We show what interface they're attached to, what's their MAC IP, what operating system are they running, when they were connected, like is it Apple, is it a phone, is it an IP device, or not an IP device, but a smartphone, a wired phone, is it a MacBook Pro, those sorts of things. And we can actually drill down and look at even further into the flows that are happening on those particular devices. So what he's looking at here is he's actually clicking on the particular device and looking at what sort of communications are going on with that particular device. So from an SLO and IP fix perspective, when we help with that, we can see actually what kind of flows and protocols are being used and communication flows between those two devices. When we click on that, we can actually go in the topology view and drill down into particular access points where we might be seeing an issue. So in this example, we're clicking on an access point that's connected to a spline, and that pulls up this page that shows you just some stats on the device, what kind of device it is, what's the model, and then we can actually click into the client journey from there, right? So from the client journey, now we're back to what we were discussing earlier, right? What is the health of the network? The idea is to create just a seamless environment for your client, right? We want to understand what issues are going on and how do we solve them. So what we're walking through now is the association authentication failures. He's drilling down into what sort of users are seeing that, what are the failures, right? So I'm looking at what those failures are. We can view the packet trace that we mentioned earlier to click on the packet trace to see what's going on there. How many clients are affected? What's the baseline, right? Is this a baseline or beyond baseline? Beyond that, and then drilling down into more of the issues from a protocol perspective or a vendor perspective. So maybe you have, for instance, a correlation between Samsung devices. Maybe a lot of Samsung devices are seeing a particular issue. Maybe they had a particular upgrade that caused them to authenticate or not be connected properly. And then beyond that, we can actually drill down into the root cause again. So this is pulling up that page we were showing earlier where we're looking at, okay, there's high contention. How do I solve that, right? Go into the radio settings and change the operating channel to auto, right? Things like that, right? So ways that we can actually give you recommendations to improve the health of your network. So cool. A couple of new things that we're working on from the CloudVision perspective is location tracking. So with BLE, we're able to associate, you'll see these little APs here. We're able to look, and if you drill down to one of these APs, you'd be able to see exactly where users are connected, and we do that with BLE. And you can do these overlay maps here where you can drag and drop these APs into the particular rooms. And then with the location tracking, we give you an estimate on where those connected users are located. Beyond that, we can also add in if there's problems, right? So if we know there's a particular problem with a particular host, maybe we see a bunch of problems in the particular executive briefing room. Maybe there's a connection issue in there. We need a performance site survey. So this gives you the analytics and the power to have much more visibility in your network than you've ever had before. So in summary, CloudVision is the all-in-one management platform, truly all-in-one. It provides all the functionality for your wired, your wireless, your containerized, your virtual infrastructures. As far as deployments, we can do ZTP, ZTR, hierarchical template configuration and management. We can do real-time bug alerts. We can do all of the configuration compliance, image compliance upgrades from a provisioning standpoint. From a telemetry standpoint, we can provide all the real-time analytics that we showed earlier for troubleshooting and identification of issues. And that's what really makes it cognitive, right? Is we're taking this platform that's a one platform, one-stop shop for all of your devices, and then giving you the logistics and the ability to make real-time correlation with events that are happening in the network with problems. Well, thanks, guys. I appreciate it. I think we're going to send out a couple questions here, which you should see in the poll here recently. Let me see if we had any, some sort of notification in this case. I'm going to look at some of the questions here and see if I didn't answer any. So Leska, I see you said it would be nice if there's some sort of notification in this case. I didn't see if there was another question beyond that or what the notification you were referring to was. Can CV do configuration management of non-Arista devices? No, but what we can do is we can connect the devices via SNMP. So all of that topology view that we were showing earlier, with LODP and SNMP, we can show you and give you stats on those devices and health on those devices, even if it's not an Arista device. But no, you cannot today manage the configuration. So we don't give you, Stephen Reddy, do you have access to CLI from CloudVision to configure switches individually? No, we don't give you access to the CLI. You can still do that, but if you look at the configlets, and we can definitely demo a lot of this, it's basically a copy and paste of the CLI. So you could just essentially copy your template into the portal as well. And the idea is that anything that you would commonly use in a CLI would be extrapolated from a telemetry sense. So anything like a show command, like if you want to do a show IP route, that should be all visualized in telemetry. If you wanted to do configure a particular configuration, right, that should also be able to be pushed out with the configlets. Do you have to buy the Z software to get telemetry? I believe so. I'm not 100% sure on the licensing. I could get back to you on that one, Carl.
I can kind of take over the licensing one as well. The licensing models at Arista are fairly simplistic and straightforward. We only really have 3 major licenses, depending on whether or not you're implementing high-end routing with our Flex license. If you're using overlay technologies like VXLAN with our V license, or you're using our platforms as a tap aggregation device, or for some of the telemetry features you mentioned with the Z. Some of these licenses are actually captured in the Flex. So, in some cases, customers can benefit from simply deploying a single license and gaining multiple levels of functionality. In other cases, there may be, no more than 2 licenses applied to a given platform. And the licenses, for the most part, are perpetual. So you buy them once, deploy once, sort of use case.
Hey, Sean, just just a couple things. The question from Ram about was really tied to the topology view, being able to identify bandwidth utilization per link. Just to confirm that there is a coding, a color coding mechanism per metric that's part of the topology overlay. Just to confirm.
Correct. Yes. Yeah. You'll see it's not like a black and white. There, depending on the utilization, you'll see it more red or more blue depending on what's going on. It's like a weather map. Yeah, like a heat map.
Also, will CloudVision run in Azure Stack? I think that's more based on a cloud approach with CVP. Just didn't know if you or Jonathan had any comments around that.
I have not deployed. I know it's something we're looking at. I can follow up on that. And I know we're deployed in AWS today as far as CloudVision Wi-Fi. We're working on Google Cloud. I'll double check with Azure and see where we're at with that.
Yeah, we're in the process of preparing to roll out CloudVision as a service. So today, and I'm not sure we covered this much, today CloudVision can be purchased as an appliance from Arista in a 3-box cluster for high availability, or it can be run in your data centers on a virtual machine. We are expanding on those two offerings here soon this year, where you'll be able to run CloudVision as a service in the cloud, if you will. So be on the lookout for more information on that front from Arista soon.
7280 are applicable for campus core if you need higher scale. Will that impact any campus features? So again, from a short answer is you can actually leverage the 7280 as a campus spline or spine device, no problem. It's still leveraging our extensible operating system, so all those features would still apply. And then obviously you can leverage the PoE feature set downstream within your leaf for access closet nodes. And that's for the last question tied to the anonymous attendee.
Awesome. So I think the poll might be done. I'll give the questions and answers out for that. So true or false, CloudVision has the ability to manage wired, wireless, virtual, and containerized platforms? 100% true. Everyone got that right. So yes, that is true. What is the name of the configuration snippets applied to the devices in CloudVision? Tags, configurates, or snippets? It is configurates. How quickly do Arista devices stream their state out of CloudVision? In real time. Yes, 91% got that. Not 5 minutes, not 30 seconds, in real time. What is the name of the analytics process running on CloudVision to process real time? I thought this one might be a little bit tough, but the majority of you did get it. It is turbines. Yes. All right, so I'm going to pass it over to Jonathan Scott. I want to provide any closing comments.
Well, first and foremost, I just want to thank everybody with a couple minutes left. Hopefully you were able to gain access to our contact information in the beginning parts of this virtual meeting. Feel free to reach out to any of us who presented today if you have specific questions about Arista products and technologies. As I mentioned, Scott Wilson and Judson are hyper-focused on the federal market space here at Arista, as well as the commercial enterprise here in the DC, Maryland, Virginia territory, along with myself. So our contact information should be readily available to you. Just want to thank everybody for joining us today and spending some time with us. Hopefully we put together content that was applicable to some of the interests that you may have, and at a minimum, you gained a larger exposure to Arista and our capabilities. With that said, Scott, if you'd like to share anything in closing.
Just as the team shared there, it was a lot of content, a lot of details, and we do have a very wide audience and perspective here that you can tell based on the questions that have come in and some of the redirects that have gone on. We're going to go back through all the questions. We're going to try to get a copy of the slides out to all the folks that have registered. And then in addition, we're following up individually as it's already been going on here today, since again, we have majority of our staff and teams throughout the Mid-Atlantic, the federal team, and even some of our folks that support the partner community directly that were online and keeping track of things that were going here. But again, thank you. It was a large investment of your time, and look forward to supporting your efforts and supporting our large customer base that's out there today.
And it certainly goes without saying that I hope everybody stays safe and healthy, during these unprecedented times. And again, certainly appreciate your time today.
Yep. Thank you all.
Thanks, everybody.